Welcome back, my friends. Let us enhance our secret messages project from the YByte Python curriculum available at www.ybyte.in. Now, secret messages is this extremely interesting activity where we use string slicing and functions to create messages which we keep as secrets. And we do that by doing what is called a transposition cipher, which means that we take a message and we jumble up its characters in such a way that it gets very hard to read. For example, here, let's say the message is meet me in the lobby at 6 p.m. One of the secret messages we do is this even odd swap, where basically we have interchange the even and odd letters in this sentence. And notice how difficult this has become to read. Unless you know what has happened here, it's going to be very, very hard for you to understand what's going on. Of course, you must with the right knowledge of the key, you can go and decode this. And once so we did lots of these. Once you decode all of this, you get the right message that you want. Now you can imagine that this could be used, for example, in to share secrets with your friends, or let's say for financial transactions, or let's say for in the battleground to keep secrets from enemy, and so on and so forth. There are many, many, many applications. But let's just look at an extremely interesting enhancement in this video, where we will generalize this whole idea of an even odd swap. Now this is a pretty interesting thought in itself, and also a great programming practice. So what we want to do really is that, previously we did this even odd swap where we looked at our message. For example, let's say the message was Python is cool. We looked at this in pairs of two, and we swapped the two letters in the pair. For example, we took Y ahead of P, we took H ahead of T, we took N ahead of O, and so on and so forth. And hence we got our encoded message, which is kind of like interesting. Now let's say I want to generalize this. Instead of looking at this in pairs of two, let's say I look at it in any number. For example, 3, 4, 5. Let's take some examples. Let's say I look at this whole group in a group of 4. So for example, I'm going to look at PYTH as one group, ON space I as another group, and so on and so forth. Now notice that within this group, I am jumbling these letters up in a very special manner, and I encode that, I sort of capture that inside this list called key. So for example, I have my key as 3102. What I mean is that the letter that's at position 0 in the original group will end up at position 3 after encoding. The letter that is at 1 will end up at 1. The letter that is at 2 will end up at 0. The letter that is at 3 will end up at 2. And I'll do that for every group out there. So this is really, quite interesting. It's like, we are taking groups of letters and jumbling them up according to this key. We can take one more example. Let's look at, let's say, a group where, let's say, we say take groups of 5. So again, we have 0, 1, 2, 3, 4. And here my key is 43102, which means the letter at position 0 inside this group goes to position 5, which means P, for example, comes to the very end. Letter at position 1 goes to 3. So notice, goes to 3. And remember, the counting is from 0, 1, 2, 3, 4. The letter at 2 goes to 1. Letter at, let's say, 3 goes to 0. So that's why H comes in the beginning. And letter at, let's say, 2 goes to, letter at 4 goes to 2. So which means that this O goes to 2. So what I end up with is another secret message. Quite interesting, H, toy, psi, whatever, right? But notice how we have jumbled up this whole thing. And if you think about it, this is really generalized even odd swap, because even odd swap is one special case of this where we're just dealing with groups of 2. So with this, we'll see how we do this, and we can make our code very general for any n. Now, the whole idea here and the steps that we are going to follow is that, like I said, we'll use a positive number n and a list called key, which will have n items to implement, let's say, this whole, scheme. We'll have to do a few things. First thing we'll have to do is that we'll have to add trailing spaces to the message, so that becomes a multiple of n. Now, why do we need this? Because remember, if let's say the message has, say, 31 items, and we are using n equals to 6, then I must add at least 5 to become 36. So I want to make sure that my message length is a multiple of n in general, and hence I will add some trailing spaces. I'll split the message then, and this will be done using slicing, into groups of n. And this is clear from the pictures that I showed you earlier. Here I'm going to split the message in groups of 4 and so on. Here I'm going to split the message in groups of 2, groups of 5, and so on and so forth. So in general, I'll split the message into groups of n. And in each group, I will jumble this up according to what I had in the key. So for example, we showed, it took an example here. key was 43102, and we end up doing what we are doing here. Now, just one, interesting observation here, that the key is, quite interesting. If I were to keep the key as 0, 1, 2, 3, for example, 0, 1, 2, 3, 4, then really I'm not changing the output. So output has become same as the input. And also, just to sort of complete this, relate this to your relate this to your even or swap. In that case, we have n equals to 2, and the key is basically 1, 0. And that's why the even and odd is getting swapped. Think about it. Now, let's just do this step by step. The first thing that I'm going to do is, of course, I'm going to define what my n is. Say, for example, here I take n equals to 6, and I define my key as 451, 3, 2, 0. Now, this is nothing special about this key, but I just have to define some key of length n, and that's what I've done. I'm going to define a function, because that's what we are always doing. So I'm going to just define a function. Now, first thing that I'm going to do with this function is that I'm going to look at my input, which is message. I'm going to look at my n and see if my message is already of a length that is a multiple of n. If it is not, then I'm going to add trailing spaces. Now, this may look a little bit confusing, but really, this should not confuse you, because remember, modulo operation gives me the remainder. So if I do length message modulo n, I'm getting the remainder. If the remainder is 0, it means the message is already good. If the remainder is not 0, then I need to add exactly n minus, let's say, the remainder spaces. And why is this? Let's take an example. Let's say n is 4. I do the modulo operator, I got 2. So which means that my remainder is 2. If I were to add another 2, then I'll be fine. My number will be a multiple of 2, multiple of 4 again. Similarly, if n is 8, I did length of, the string modulo 8, I got a 3, I need to add 5 spaces. Think about this, is not too hard, and there's some explanation given here as well. Let's first, get to our program and start doing at least this much. So, I'm just going to continue from wherever I had left. So I'm just going to say, for example, let's say n is equal to 6. And, I'm just going to follow the key that I used here. So let's just call it E key, for example, because this reason will become clear, because we are encrypting with this key. And this key is given by 4, let's say 5, 1, 3, 2, 0. Now, again, like I said, you could do any key here. You can actually generate this randomly. And I'm going to define a new function here. I could have also done it on top, but since I want to contain this, the enhancements in one place, so I'm just doing it here. So I say general, let's say swap. And I'm going to like 3 inputs, let's say message, or let's just call it, so we call it message since just to be considered with the nodes, but also we could have called it X, doesn't matter, n, and let's say key. And I'm just going to, like I said, the first thing I'm going to do is I'm going to check if, let's say, length of message, modulo n is not equal to 0, which means the length is, the length is not a multiple of n. In that case, I will add trailing spaces, and I do that just by, saying message is equal to message plus n minus, len, say message modulo n times spaces. Now be, clear about this. In one case, we are dealing with integers here. In the other case, we are dealing with a multiplication on a string, which means that I'm going to repeat that many times the string, and hence, and again, this message is a string, so this is again acting on a string. So my message will get extended by that many spaces. Now, having done this, let us think about how I can split this message. Like I said, we can use slicing for this purpose. Basically, as we saw in the picture earlier, I'm just sort of dividing my message into many slices, and these are basically slice which is like message 0 and 1. Now remember here, it starts, stop, end. So I'm starting at 0, stopping at n, which means that I'm going to get elements until n minus 1 and in a step of 1. So basically, this is quite of straightforward if you think about it a little bit. I am, just going, for example, if you take an example, n equals to 4, I'm going from 0 to 4 to 1, 4 to 8 to 1, because basically this will give me 0, 1, 2, 3, this will give me 4, 5, 6, 7, and so on and so forth. Now, obviously, I don't want to write this in a very verbose manner, so I'm going to use a loop to solve this problem. In fact, a for loop is just perfect for this. However, you have to pay attention to this, how this thing is working. First thing first, I'm going to take a variable kk. Again, kk is just a counter variable, and I'm going to run this in the range, let's say, int length message by n. Now, I need to convert this integer because this division operation gives me a float. Now, The reason this is working is because the slices that I'm going to create are exactly equal to length of message by n. And I'm doing it, like I said, kk goes from 0. So first slice is 0 to n to 1. Second slice is kk becomes 1. So n to 2n plus 1 and 2n 1 in steps of 1 and so on and so forth. Just think about it a little bit. You realize that as kk traverses the for loop, the temp holds the appropriate slice for every message. So let's just go back and do this. And I come to my code here. Now again, I must make sure that this is indented inside the function, so that indented so that stays inside the function. So I just go and say, for example, for kk in range. Again, I just write this code. Let's say len message. So I have to be careful here. By n. In this range, I put a colon. All right, so kk in that range, I will do temp equals to, let's say, message, kk times n. Now think about this a little bit. This is quite logical. Kk plus 1 times n and in steps of 1. So notice, remember, this is start, stop, and end. And I can just, just to be sort of understanding what's going on here, let's just write, for example, print temp. And for that purpose, for any of this to happen, I must now call my function, because right now I only defined it. Let's just say, let's say general swap, say, I'll take, say x. Remember, now x is coming from top here. I had defined x earlier, which is meet me in the lobby at 6 p.m. So I just call it, let's say, general swap x. And I will, let's say, give n of, say, as I'm giving, say, 6. In this case, I just say n. And I just say, for example, e. Now, bear in mind that, the n that I'm defining outside is different from the n that's inside, because inside the function is all local, right? So these two are really not interacting with each other. Now, when I'm doing this thing, notice I get, the temp is being printed again and again. And what happened here is I got slices with, 6 elements. So it was 0, 1, 2, 3, 4, 5. That is 6. 0, 1, 2, 3, 4, 5, and so on and so forth. You can convince yourself that there are exactly 6 elements on each of these. And in fact, the message has also been probably, some spaces have been added to it in the end. So basically, this temp now contains every slice, every piece of it. Now I just need to jumble this, and how I will do this is also quite interesting. Remember, the jumbling is contained inside this key. So what I'm going to do is that I'm just going to run a for loop once again on every temp. Now this for loop will run with, say, jj as a counter variable. I'm just going to iterate jj in this key, and all I'm going to do is that I'm going to say, okay, look, I have an empty string s to start with. I am going to, append this string with temp jj. So think about it. What will happen here, right? So when I first start, my temp is the very first slice. I'm going to put temp 4, then temp 5, then temp 1, then temp 3, temp 2, temp 0. In other words, I would have jumbled up my temp, my that specific block. Then I go to the next temp and so on and so forth. And that's how this thing works. And eventually I'll just return my S. So let's just see this in code. I can remove this, I don't need this print because this is going to confuse me. So I just go in here and I say for, say, JJ in key. Now remember, key again is being passed from here. So I don't need to worry about, I don't need to call it E key in this case. I say for JJ in key, S is equal to S plus, for example, temp jj, right? And if I did this, of course, I must, first define my s over here. So I'll do it outside the for loop. S is equal to an empty string, completely empty. And after this loop is over, now notice I must still indent this because I want the return statement to be inside the function. So I just go and say return s. Now notice here that this is indented for this loop. So this is a for loop that runs inside the outer for loop. Basically, this for loop is running for every piece, every temp. And that's all I really need to do. If I see this now, if I did general swap, and let's just call it, let's say, X, let's say, ENC, since I'm using, let's say, general, and this is equal to, let's say, general swap. Now, if I did this, I'm going to, get this. So if I look, let's say, print X, say, ENC general, I have got quite a complicated string. Now, just in case you're wondering, this is, just very, same as even odd swap. Let's just do a very quick test. If I were to do, let's say, even odd swap of, let's say, so xenc general, I will not get the original string because obviously this string needs its own decoding. This algorithm is totally different. But you realize that this is very general now. I could choose another n and we can do that as an example. Let's say I just go and say n equals to say 3. Now my e key obviously must change. So I go and say e key is equal to say, for example, let's say 2, 1, 0. Right now my e key must always have 3 elements and they must go from 0 to say n minus 1. Let's just say I do this. Now my code will run and it will give me a different, so if I look at, let's say, xenc general, I will get something else, right? And that's because now this is running very, very generally. I'm doing the splitting in groups of 3. And in fact, like I was telling you earlier, we can do an even odd swap also from here by setting n to 2 and saying e key is equal to, let's say, 1, 0. So what this means is the 0th element will go to 1, first element will come to 0. This will do exactly my even odd swap. If I, let's say, now look at xenc general, I'm going to get, notice this is exactly the same as what I had for the even odd swap. And if I were to just, do this, let's say, if I were to say even odd swap this guy, even odd and odd swap this, I'm going to get the message that I started with, which is meet me in the lobby at 6 p.m. I hope you found this interesting. This is actually quite nice. We'll see how we can decode this in the next video. But in general, if you think that this way of learning Python is interesting for you, gets you thinking, makes you understand things much, much better, do look at our website because that's how we learn Python programming, through such fun activities. Take care. Thank you so much. Bye-bye.